Okay, so again, today we're going to go over if statements. There's two ways you can write code. You can write it in the shell, which is what's on the screen here. You can also do it in the console, which is it's basically a text file that you then run through Python. Why would you use an if statement in the shell? Anyone have any idea? So you can test the one thing, like, I think my code should do this, or does, if I were to type x is 10, if type x equal int, actually you don't even need if, but print true. So if I just need to test my code, how do I determine if the type of a variable is equal to this? Okay, so maybe I don't need the if statements. Let's just go, what if we did this? Because if you don't put the if statement and just have this Boolean expression, it will tell you true or false. So this is a great way to be like, okay, well, what I had in my code isn't working. Why was that? Well, it's because my if statement, this is not true. So you could go, well, what can I do? Can I do, so maybe if I do this, alright, well that's not going to work. Let's try this. And then this. Okay, well I can't determine if a variable is class int this way. If you keep messing with stuff, maybe you can. Okay, well I got to figure out a different way to do this. What's another way we could determine if a variable x is specifically an integer? Now there's another way that we're going to look at after we get through our quiz, because we didn't cover this. I don't think I covered it with you three. I know I didn't cover it last semester with string methods, right? We didn't go over that, did we? To determine if which is basically if a person types in a string, is it made of letters? Is it made of numbers? Is it made of either or? Does it have a space in it? Does it have blah, 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 blah? So it's basically evaluating what someone types in and manipulating the string. Did we go over that with Thorne, Adam, Maddie?
Yeah, I'm not sure.
Okay. It depends. Some classes I was able to get to it, other classes I wasn't. The second spring semester is 2 weeks longer, so sometimes I'm able to get to it in the spring semester. So what do you guys think? How can we determine if a variable is a number, or specifically is an integer? Yeah, so this isn't working. So in our code, let's say for example, we were trying to determine if a variable was an integer. Knowing what you guys know, how do you think you can do it? Now don't forget, you can change integers into strings, and you can you can do a bunch of different stuff.
Are you saying that you want it to see if it's an integer, and if it's not, then change it into an integer?
Nope, I just wanted to say, I want an if statement that tells me whether or not a variable is an integer, so then that way I can put it back into here where, define fun1. I need it in here, right? I don't know how to do this, and instead of running my code, I just need to test one line. So this is when you would use the shell to you would use if statements inside of a shell when you want to test one specific thing. I do this quite often. Does anyone have any idea? Any guesses? While you guys are thinking, Brendan, did you get Python up?
Yeah.
Okay, cool. I can think. Oh, Thorn.
Could you do if x equal int x, like the integer function of x, then print true?
Yes. So let's do if we had y is 10, and if we did y is int y. Oh no, that's not what I wanted. Y equal. Sorry. Okay, good job. So that's basically saying, does the integerized version of x, is that the same as x? As you can see here, y is a string 10. Does the string 10 equal the integer 10?
No.
No. So that's one way. That actually probably is the more efficient way, because I had a different way. Yeah, mine didn't even work for that. Mine only determined if it was an integer or a float, but it didn't rule out string. So I had an idea. I did, if the str of x period in, so if a period is in the stringified version of x, which is 10, is there a period in here at all?
No.
So now I know it's not a float, but I don't know that it's not a string. And then you could do, and then the other way, yeah, that was a much better way than mine. I'll flat out say that. Because another way I was thinking was, can I do integer division to determine, can I divide it by something? Because that would rule it out if it's a string. So if I have x divided by 1, wait. Yep, no, see, that still didn't work. No, it would if it y divided by 1, you'd get an error. But now we'd have to deal with this error, which is something we will cover, just probably not before the quiz, the review quiz. So that's one reason, one way why you would use the Shep. Oh, I do not like this. All my good masks are dirty. So I got the one you keep in the car in case you forget one.
Right. Okay.
Sorry. So now it looks like I'm not covering my nose. Okay. So this is when you would use an if statement in the shell. Oh man, my code's not working. Why is it not working? Is my if statement even evaluating the correct things? That's when you would use this. Because I don't want to run through the code, I don't want to type in my inputs, and I don't want it to read the file. I literally want to go, if it's an integer, can I use a statement, an if statement, to do what I want it to? So we're going to jump over to, did we go over functions?
Yeah.
Okay. So again, define function 1 followed by a set of parentheses and a colon. This is how you reuse code, is by writing it into a function, and then as many times as you want to run that function, you call the function that many times. So again, right here, this is called defining the function. That's what DEF stands for. Define whatever, and then whatever's in blue is the name of the function. And we won't get to this today, but whatever's in the parentheses are the arguments or the parameters or the variables. All three of those have very specific meanings, and I can't remember the difference. I believe the correct term for anything in there is an argument. I think.
Yeah, that sounds right.
Yeah, because then there's also parameters, but parameters have a different specific. I don't care which term you use, but there are very distinct definitions, and I believe it's in the book. So if you get, while you guys are working, I'll look it up. Followed by the colon. Now notice everything, if I hit enter, I'm indented 1. So everything that's indented 1 is a part of this function. And as soon as I get to here and it's not indented at all, this is not a part of this function. And even if you run it, Oh, nope. Here we go. Student resources. So even if you run it, you're going to get expected an indent block, meaning this, you need something inside of this function, otherwise it breaks. So you would print x is 100 or whatever. Now when we run it, I mean, it doesn't actually do anything, but the function isn't broken because there's something inside of it. So again, the way we write if statements, every if statement block has to start with if. So if x equal 100, what do we want to have happen if x is equal 100?
True.
Print true. All right. Now, I'll break this down. So this is the if statement. This is a Boolean expression, meaning it's true or false. It can only be one or the other. And this code here only gets executed if this is true. You can throw not in here, which would mean if this whole thing means false, because this would be, what's not true? False. So you can do that. Really, if you're using like x equal 100 or x equal 100 or a sort of number comparison, I don't know if I would do that. Basically, you use if not, like you can do, you guys don't have to type this in, but you could do if x in list 1, if x is not in list 1, print true. If it is, so you can, that's more for if Maddie not in class list. If she's not there, we need to add her, but if she is there, don't add her. That sort of stuff. If you're doing, instead of just numbers, if you're evaluating strings or something like that. So I'll get rid of that. So if x equal 100, print true. Then following this, we could do one of two things. So we could do else, and then if x is less than 100, and then we could do, well, else but I don't like that. I don't like this if, else, if, all that sort of stuff. Right? Do you guys remember? Elif, yep. So instead of, that's what elif means. It means else if. So this is what it breaks, an elif breaks up into this right here. We obviously don't want that, so we're just going to go elif. Oops. Does anyone remember the difference between having elifs here or having just ifs? Doran?
So the elifs, once it finds the correct one, if it finds it true, it won't do the ones afterwards, but if you have ifs, it'll try all of them.
Yes, so two reasons. One, it makes it slightly less, makes your code slightly faster, maybe a few milliseconds, because once it gets one of these true, it ignores the rest. It doesn't even try the rest. So you can basically think if you have if and elifs, you will only ever get one answer. Only one of those will happen, but if you have a bunch of ifs, So let's do this. So if x is less than or equal to 100, if x is greater or equal to 100, or if x is equal to 100. What? They're all true, yes. Brendan?
What you should do is you should just get rid of the less than or equal to and greater than or equal to, put greater than less than, that way you can only one.
That's what we just did though.
Yeah,
Unless you want
that-
to print like two.
Yeah, no, this is an example. You're totally right. You're totally right. But so here we have x is less than 100, x equals 100, x is less than 100, x is greater than 100, or greater or equal to. We get 3 answers. If I put elif, what's it going to display?
First one is true.
It's only going to print true. So that's the difference between an if statement block with just a bunch of if statements and if with elifs. Now the last thing we can do is we can throw an else in there, which basically covers in this block anything that's not covered in these 3 if statements. So else print you didn't How do I know they didn't enter a number? Right? So if I have else, So how do I know they didn't enter a number? Why can I put that? Why didn't I put you didn't put a valid option?
Because it would have told you if it was greater than 100, less than 100, or 200 was a number.
Exactly. So any number I type in is either going to be equal to 100, less than 100, or greater than 100. So if they type in anything that's not a number, well, now I know, and that includes integers and floats. Because can I compare 99.9 to 100? Yeah. So I know they didn't enter a number because one of these 3 would have been true if they had. Now our code, we've hard-coded what x equals, so it's always going to be true. But if we did, let's say the person typed in hello. Oh, great, we're also going to get an error anyway. So because we can't compare a number to a string. So that kind of... Well, then what do we do? You use a try and accept, which is something we'll get to later. So try and accept allows you to code around if your code is dealing with numbers and they type in a string.
So if it says if you get an error, then ignore it.
If you get an error, do something else.
I think we should.
You have to be specific. You would say if type error. You can just be if I get any error, it doesn't matter, do something. Or you can be if I get this error, do this. If I get a different error, do something else. So that's basically how they how you can actually write your own error code to yourself. So you can put, it's called raise, raise, and then you can type stuff in here. I can't remember 100% how that works, but it's very simple. It's raise, and then I think you put a string. I think that's wrong. Oh, wait. Yeah, so I raised our own error. Yes.
I have a good question that's like a bit unrelated. If you're using the tab key, how do you like anti-tab? How do you get that?
Oh, so if you highlight and hold control
Yeah.
and you tap close bracket, scoots it over one indent. No, that's open bracket. So I'm just going to say left and right bracket.
Oh,
Left bracket scoots it to the left. Right bracket scoots it to the right.
all right.
But if you do have any questions on that, up in format, it says indent region. It gives you the controls if you want to comment stuff out, all that sort of stuff. So that's right under format. If you want to change the look, I think Adam is using not dark mode, so his is all white. if you go to Options, Configure Idle, and you go to Highlights, you can pick do not change the font or the spacing. Only change colors. There is a very specific reason, because as your code gets longer and you have more indents, because indents determine whether or not something is inside of an if statement or a for loop or a function. If your spacing isn't what I'm used to seeing, and this is purely selfish, if it's not used to the spacing I'm used to seeing, it's harder for me to help debug your code, and it's harder for you as well. So change dark, you have classic, dark, and I honestly don't know the difference between new and classic, but I like dark. Okay. Questions so far? What are who can give me an example of a relational operator? That's a logical operator. But yeah, that's an and or not. We'll get to that in a sec. A relational operator determines the what? Relationship between two things. So what is that? With that hint, what do you think? Greater than, less than, equal to. All of those are relational operators. It determines the relationship between two objects. And there is equal, whatever. Greater than, less than, does not equal. So exclamation point, equal sign means does not equal. So x doesn't equal 10. I haven't defined x. So x doesn't equal 100. We'll get true. Which is also why I would say don't use not with numbers. Do it something like this. Just because if not can get really, you're like, okay, so x does equal 100. However, if it does not equal 100, this is gonna like just do the exclamation point. Greater than, less than, and then there's just greater than by itself, less than by itself, and I believe that's all of them. I think there's 6. And you can use that for true or false. You can use greater than and less than with strings. What was that, Adam?
I would say no, you can't.
So you're going to say it's false. Anyone else agree or disagree? What?
Does it use like the use mode so that would it like compare the actual values of this string like by the numbers, but if you wanted to actually do like this, like you have like true and false, like if you wanted to actually do that, I think you need to use like a different like method or something.
So yes, what it does is it compares the ASCII values of each thing on your keyboard. So unfortunately, Adam, you were wrong. Sorry, it is true. Do you guys know what ASCII is?
Yeah, a little bit.
So ASCII is a numerical value given to everything on your keyboard. So lowercase a is number 96. Uppercase A is 70? No. What's 96? 59 or 60 or something like that. And what you can do, this is how a computer determines alphabeticalness. So if we do A is greater than B, that's false because A is 96. Is 96 greater than 97? No, obviously not. 96 is less than. So the way this works is you can kind of think of it, if you're comparing alphabetical orderness, you can either do it this way with if statements, or there's also sort if you have it in a list. But what you can think of it is, how many pages in a dictionary do I need to flip before I get to this number, to this letter? So A is less than B, so I have to turn fewer pages in a dictionary to get to A. So A is alphabetical first. Does that make sense? Okay. So if I have Mary is less than Mark, which word should come in the dictionary first? Mark. So this comparison is going to be true or false? Correct. So what it's doing is it's basically saying Mary is whatever number it is, like 90, so it's like 1010 or 110 or 150, I don't know. MAR, that's the exact same, but Y and K are different. K is before, K has a lower ASCII value than Y, therefore it comes in the dictionary first. Last thing, is this going to be true or false?
Can't remember what you said.
A is supposed to be smaller, right? Yeah.
Which A is smaller?
Capital A.
Lowercase.
So,
Yes. So in Python, in a computer, capital letters come before lowercase letters. So if I were to do this with, say, right? If I were to say, Maddie, in your human mind, which word comes first in a dictionary? Something a capital A or a Z? Capital A. Oh, I did this wrong. Hang on. This should be capital Z and lowercase a. You would say, which comes first? The word that starts with lowercase a or the word that starts with capital Z? We don't have really a differentiator between uppercase and lowercase. To us, it's A. It's not uppercase or lowercase. It's A. The word starts with A. Every word possible that starts with A comes before any word possible that starts with Z. In a computer, that's not right. Uppercase and lowercase have different values. So that's something you guys just got to be mindful of. Now there are ways to nullify that and compare the lowercase and the uppercase version. Again, we'll get to that when we do string modifications, and there are some things with lists if you want to sort and ignore case, but we'll get to that. Today is just if statements. All right, so it's been almost 40 minutes, so we'll go for another few more minutes, and then we'll have a break. Questions so far? Is this ringing a bell for you three? Yeah. Okay.
What's the lowest like keyboard button you can press for ASCII?
Well, it's nothing, like 0, like null.
But like, what's the lowest like actual? Because on Discord, me and my friends are trying to figure it out because we want our names to go on top. And the lowest we got was like exclamation mark, but I don't know if there's
So the ASCII table, the lowest value
isn't actually typed.
that you can actually type.
Yeah.
Backspace is 8. Horizontal tab is 9.
No, if we can like put it
it's
in.
1, 1, there's 1 something else.
The number 1 is 30 is 49.
But so yeah, it's exclamation mark or space there.
How is that dumb?
I don't know, it's just, I don't know, it doesn't make sense. It's like, they're already numbers, so why change them?
So it'd be
Because if you have, like, 0 needs to be nothing. And then, well, it's basic. I don't know why they picked it, but it kind of makes sense to me to, like, get all of the things that humans typically don't really type at the beginning. Then I don't know why they did symbols first, but whatever.
like what's the very last one? What's that say?
This one?
Yeah.
Delete. So that's the delete button.
Oh, I thought it's deli.
Oh, man. You just had to bring food into it, right? Man, I'm hungry now.
Sorry.
A deli. But then, yeah, so you got shift. I don't know what a carriage return is. Vertical tab, space. So the earliest ASCII variable, whoever was asking, is exclamation point.
Okay, that's what I thought. Because we couldn't find anything for that.
Yeah. And then if you always want to be last, put tilde in
Put
there.
32 tildes in a row.
You would always be the last person.
Yeah.
They'd probably like you need to have the letters or something in there, but
No, it didn't let me do that.
oh, it did.
Yeah.
Oh, well then.
There's like a max of 32. So max of 32.
Oh, so A is 97, not 96. So I was off. And then capital A is 65. So the lower this decimal number, the earlier the alphabeticalized, the whatever. You guys know what I'm saying, right? Okay. This is how it compares letters, is using this decimal here. And then the cool part is your computer takes those numbers, translates those numbers into binary, sends those numbers through your CPU, and your CPU is like, all right, well, I just got 01100010001000000. The output of that is 0100001110000. Then that gets translated into ASCII. That ASCII gets translated into letters. Those letters get put on your screen. Yeah. Everything in your computer is doing gets broken down to a 1 or 0. That blows my mind. The pixel in the corner, the colors determining those pixels, the exact color of those pixels breaks down to a 1 or 0. In multiple places, by the way. Gets broken down on my computer, gets broken down up there. Computers are dumb, by the way. They only understand two things, a 1 or a 0, and they do exactly what you tell them to. The biggest issue is what you tell it to do is not what you want it to do. I want you to do this, but I'm telling you because I screwed something up or I wrote something wrong or I don't understand what I'm doing, which is most of the time, and it doesn't work. Okay, so.
Do the internet browsers use binary too? For information?
At some point, yeah. So the way data transmission works, so this is going into computer networking, is you get packets of information sent. So all the information that you get sent to your computer is broken down into packets that have certain sizes. You can change the size of those packets depending on what you're doing, and that's basically what happens with a DDoS attack, which is dynamic denial of service, which is basically, so right before the 2016 election, did you guys know that like a third of the internet went out?
What?
Like a third of the websites on the internet went down. But it wasn't the websites that went down, it was the phone book that told websites the number of each website, the IP address. And the way that happened is there are these things called DNS servers, domain name system or something like that, the DNS servers. And if those go down, your information doesn't know how to get to the website server. So someone took one of those down, and a third of the internet relied on that specific server. And the way they did it, you can think of a denial of a DDoS attack is that door right there allows one person per second into this classroom. What do you do if 1,000 people tried to get through that door in 1 second? No one could get in, right? Because it's one person per second. Maybe 2 people a second if needed, but it can't do that for long term. So if you have 1,000 people trying to come through that door at once, no one can get in, therefore no one can get in this classroom, therefore no one can hear me speak. That's what a DDoS attack is. Is one way a DDoS attack is you overwhelm a computer's ability to handle traffic and therefore it breaks. Not random, but it's like those DNS servers are capable of handling like I'm going to make up a number because I don't really know, 10,000 requests a second. So probably, but I'm just going to say 10,000. So what these hackers needed to do is they needed to multiply that by like 1,000 in order to break it. So what they did is they had computers all over attack one server. All these bot computers, these bots, attack one server at once, crash it, and then, all right, well, there's no one, 30 of the internet. Like Twitter was that. We were freaking out because I thought like we broke something. Me and Mr. Vishnoff are like, why are some websites working and why are some not? We don't know what's going on. Is it the filter? Is it the firewall? Is it this? Is it that? What's going? And then we found out that it was like, well, a DNS server went down. So those websites you just can't get to. Deal with it, people. There's nothing we can do.
Did they get back up?
Yeah, it was a couple hours. I think they did it 3 times that day. They were able to, like, they got it back up, they attacked it again. They got it back up. I think. I can't remember how many times it happened, but yeah, it was crazy.
Third internet on one DNS server.
There's only, I think there's only like 7 DNS servers for the United States. There's only 3 electrical grids.
Was that part of like the election, like conspiracy?
Some people, my brother thought, like, listen, this is before, like, he was like, oh my gosh, if on election day they did this, that could be really, really bad because it would really prevent people from knowing what's going on. It may influence the election. It didn't happen. It didn't happen to my knowledge after that, but it's crazy. All right, so we're gonna take a break. I'm gonna pause this recording, which I'm so glad that that's a function. So we'll come back at 10:30. All right, here we go. So the last thing is, let's do y is 10. So you can, if we wanted to display true when x was equal to 100 and y was equal to 100, we could do 2 things. We could have 2 individual if statements. So if x equals 10, if x equal 100, if y equal 10, then print true. And we would get true. So you can have an if statement followed immediately by an if statement. And the reason you would do that is you want something to happen here. So print x equals 10 or 100. So you could do something like that and you would get 2 outputs. Does that make sense? You could also, so that would be, if the weather is rainy, print bring an umbrella. If the temperature is greater than 60, don't wear a coat. If the temperature is less than 60, wear a coat, that sort of thing. So you have sort of one overarching if statement, and then within that you want to have different, and then you can have, if it's not raining, you can do these other things. Yes, Adam?
Can you put if statements inside elif?
Oh, yeah.
Okay.
Yeah, so under here I could put if y equal 10 for sure. And then you just have to make sure that's indented. So this is totally cool. So this would be if I have different sorts of scenarios. So the one that's coming to my head the quickest is poker. So if I have a 2, that's not great. And then you have, well, if I have something that's less than a 5, or if I have something that's less than a 6, that's better than if I have something that's a 7. And the reason that is in Texas Hold'em, if you have a 2-6, you have a possibility of getting a 3-4-5. I don't know if you guys know how Texas Hold'em works, but basically each person has 2 cards. Then there's a communal 5 cards. And between the 5 cards on the board and the 2 cards you have, you need to make the best 5-card hand. So if I have 2 and a 7, and they flip them over and you get 3 cards, and then a 4th, and then a 5th. And in between each one, there's a round of betting. Or you don't have to bet. So if you have a 2-6, it's possible to get a 3-4-5. So a 2-6 is better than a 2-7 because on those 3 cards, I can't connect 2, 3, 4, 5. And that's called a straight, and that's actually a really good hand. A straight's really good. But if I have a 2 and a jack, jack is I could get a pair, and a pair of jacks is a pretty good for a pair. So a 2-7 offsuit is the worst starting hand in Texas Hold'em. But that doesn't mean you can't win with it. Life lesson there. Boom. Just saying. You could start out with pocket aces, which is the best starting hand, and lose to someone who has 2-7, depending on how you play, and depending on chance. So, just saying, life lesson. You can do whatever you want with 2-7. Anyway, I should get that. I should do anything with deuces 7. 7 of deuce. So I say all that to have, if you have multiple scenarios that you need to code for. If I have a 2, if one card is 2 and my second card is 6 and less, I have a higher chance of winning than if it's a 7. But if it's a 8 to ace, that's better. So you code in such a way that this is my overarching issue. Inside of this, I can have a bunch of things. This is my second scenario. Inside of that, I have a bunch of different scenarios, etc., etc. So you can. Now, if I want something to only happen, right? I don't care. I don't want to display x is 100. I only want something to happen when x is equal to 100 and when y is equal to 10. I can do this like I have been. It evaluates this, and then it evaluates this. But what I can also do is I can put and. This right here is a logical operator. That's the term for it. Knowing that is important because I may say you have the wrong relational operator, you may have the wrong logical operator, you may have the wrong Boolean expression in when I'm looking at your code, and I expect you to like, so if I have the wrong logical operator, it should be or. And what this does is this line of code here, this print y equals 100, will only happen if x is equal to 100 and y is equal to 10. Make sense? Now, if I do or, what does that mean? Only one of them needs to be true. Yes. So normally it would be, let's see. If it's raining and sunny, display something's wrong. Because if it's raining and sunny, uh-oh. But if it's rainy or sunny, bring a coat. If it's rainy or snowing, bring a heavy coat. If it's rainy and cloudy, bring a hat. Right? Does that make sense? Like you can code, you can kind of just say, you can read it out loud. If x equals 100 or y equals 10, we're going to do this. If number of students in this class is 4 or students in this class is 10, I'm still going to teach it. However, if students in this class is 4 and 10, again, something's wrong. You can't have 4 and 10 people in here. So does that make sense? Okay. Any questions, comments, concerns, critiques, criticisms, cookies? No one has cookies. Okay. So I have saved this in the student resources folder, so you all have access to this. Again, every time I do code in class, I save it to the student resources folder. So if you miss something, or if you don't want to type everything I do, you immediately have access. You have access to this as I'm writing it. You just have to download it, and when you download it, you will have the version that I just saved, typically. Unless I hit save, you download it, then you may have the previous one because it didn't have time to upload and sync. However, in class, you guys have this. This is also if you guys, or lady, are sick and you missed the class and you want to see my end result, or you want to see the code as you watch the video, which is also why I record the video, put them up on YouTube. I put a YouTube playlist announcement so you guys can, so you all can go to it and watch if you would like to watch yesterday's or Tuesday's syllabus, me running through the syllabus. Or if there's ever a time when I'm like, it was on the syllabus, and you say, you didn't go over that on the syllabus, I can go, yes, I did, Adam. It's right here. You owe me your test right now, etc., etc. So, if you guys don't have any questions on if statements, I'm going to save this as functions, and we are going to do the difference between review functions. We're going to go over the difference between a void function and a value returning function. Does anyone know which one this is. Is this a void function or a value returning function? Thorn.
Looks like a void function.
Correct. What makes you say that?
There's no like return command to spit out its output wherever it was placed.
That's exactly it. A value return function has the word return in the function. Very easy. Now, why would I use a value returning function if I can just display stuff? So a void function will display stuff, and you can create global variables. I don't recommend it. Right now, the smaller your code is, it's okay to have global variables because you're not going to have as many like cross connections, I guess, which is not the right word, but you kind of think of it this way. If you had to name everyone in this room, it'd be pretty easy because you only got 6 people, and they can't have the same name, right? Because it'll break everything. However, if you had to name everyone in the world a unique name, that'd be really tough because as soon as I name you Adam, and then 600 people later I name someone else Adam, well now you guys have the same name, and now everything is screwed up because I may be wanting to talk to you, but I'm talking to him. So we don't like creating global variables because they increase complexity when debugging and writing code. So what a value return function does is it returns a value. So this is an example. So that's an example of a void function. So the only difference in a value return function and not is if I return x. So you have to have this, you have to have the command return in a function for it to be a value returning function. And what it does is whatever is here gets sent back to it being called. So if you do this, you may get an error. I don't know. Okay. I'm not returning x. I want x to be returned, and then I print x. So I should get an error of printing x. X is not defined, right? Does that make sense? I currently don't have x defined anywhere that's not inside of a function, which now makes me have to explain scope of variables before I go any further. So the scope of a variable is where it's able to be used in code. There's 2 options. There's global and local. Global means it can be used anywhere in the script. So G is 100. This is a global variable. It is a global variable because it isn't defined inside of a function. These 2 are local variables because they are created and defined inside of a function. You cannot use these outside of the function. You can use this anywhere, including inside of a function. That's the difference between global and local. If I want a local variable to be created, if I want it to be a global variable, I say globalize x, and then I define x. This is how you make a local variable a global. Does that make sense? Stockton.
If you like edit the global variable within a function, does it become local?
Let's find out. So we print x, we return x. I actually don't know where that's supposed to be, but this is going to be, yeah, so we print x here inside of the function after we change it, and then we print x here, and that's global. So if you change a global variable inside of a function, it does change it everywhere else. Adam,
Do you want like global beginning or end, like end?
doesn't matter. This has to be before you create it.
Oh,
So I can't have X here, at least I don't think so. I can't then go, I think I'll get an error. Yeah. Name X is used prior to global declaration, so you have to declare it as a global variable before you, which is the only time you do something to a variable before you declare it. Okay, so this is a global variable. Questions? Return, all right, so I'm gonna get, actually I will leave X like that. I will comment out, that, okay. Print X, return X. Again, when I run this, I'm gonna get an error saying X is not defined because even though I return it, I didn't properly call the value returning function. Now I'm gonna, you guys remember how to use random, right? Import random, num is random dot rand int from 0 to 10. Print num. Right? Does that make, does that? Oh well, I can't do that again. Oh, this mask just hit my eyelashes. Okay. So I have a random number from 0 to 10. Remember when we created our function and gave it parentheses? What if I gave it numbers in here? Does this look a little similar to this? That's because this is a function with parameters inside of a different file. That's how that works. You can also, I didn't cover this with Maddie, with you three. I'm going to call you the old class and then the new class, if that's okay. Okay, I don't think I covered this with the old class, but if you type as R, you no longer have to type random. You can do r.randint, so it saves a little bit of typing. And I think if you do as star, you don't even need the R. I can't remember how that works. So it must be from random import. All right, just do this. r.randint. You guys remember the old class? You guys know why I have to import random and then do random.randint?
Random is like a
It's like a function
package
that
sort
you
of, it's like not automatically integrated because
Yes, so it's a module, and a module is a pre-written file that's installed on your computer when you install Python that has pre-written lines of code. So instead of you having to come up with the code every single time to write a random number, what the creators of Python did say, that's a really common thing you need to do in coding. We'll write the code, save it in a file, and then if you want to use it, you just import it. We will learn how to do that with our own code later this semester.
can make your own module.
You will make your own module, and then you will load it into your code. It's not that hard, but if you mess up, so like if you find the random file in your computer and you mess with it, random won't work. So please don't do that.
Can you like download modules from the internet?
Of course, yeah. We're also you remember how we did pip install Pygame?
Yeah.
That's installing a module from the internet.
that's how I build everyone in our class. That's because I use the module.
Yep. Oh, my screen went black for half a second. This one. So this is a function that if we were to look at this function, it has a return in it. And what that allows us to do is it can take everything a function does, all of the math, all of the computation, we can distill that to one item and then have that item be the value of a variable. So let's do, I'm going to make this actually a lot more simple. So I'm going to get rid of that. Define fun2 return the number 10 and define fun3 print, or let's do this. Num is 10, return num. Num is 10, print num. And this is one thing I didn't get in college. I did not understand return versus print. Right, and I'm going to blame the instructor, not me, because I was super smart in college, and I never failed anything, and I never got anything below an A++. Plus. It's actually totally wrong. I got a C my first semester. Okay, so okay. So this right here is a void function. This is a value returning function. When we run this, hang on, did I screw something up? Probably. Okay, I need to stop running this because that's confusing me. So, you guys see what's happening here? I print num here, which is this guy. I then have x equals fun3. I print x, I get none, as opposed to print x here where I get 10. What this is doing is this is basically saying whatever you're returning in this function, that is what x equals. So you could do this for taxes. You could write code that does stuff and save all of that work to a variable, which is very useful, which is exactly what we do when we call random. We have random do a bunch of calculations and then give us a number. That's exactly what we're doing here. X, because this doesn't return anything, we can make a variable equal a function, but we get none type, which means it doesn't actually equal anything. Whereas if you return something and then print it, you've now saved that and you can use that in other places. So again, an easy way to do this is with like taxes. So I give you a salary, your code figures out how much taxes I'm going to pay, and then it gives me that number back, and with that, I can then do more information. I can then go, okay, I'm going to pay $10,000 in taxes this year. Well, what do I need to save if I get paid twice a month? Well, I got to divide it by 24, and my wife gets paid every 2 weeks, which there is a difference. If you get paid every 2 weeks, you get 26 paychecks, basically. If you get paid twice a month, you get 24. So, and one is bi-monthly, I think it's bi-monthly, and one is bi-weekly. Bi-month, I think. So, if you're filling out taxes, not that you guys have to do that yet, just be aware that if you get paid, there is a difference between getting paid every 2 weeks and getting paid twice a month. So if between me and my wife we're going to pay $10,000 in taxes, wow, I get paid 24 times a month, or 24 times a year. She gets paid 26 times a month. How much money per paycheck do we need to put away for taxes? So that is where you do something to figure out how much you're going to owe in taxes, and then you take that number and then do things with it. And that's the value of a value returning function. Does anyone have questions on that? Will, are you good? Okay, cool. We have about 9 minutes left. I could give you the homework, but that contains loops and lists. I think, okay, so I'm going to start loops. The homework won't be due Monday. I won't give you homework over the weekend.
So is it still assigned?
It's a sign. I'm just going to change the due date. So if you would like to get a jump start on it, you can, but you don't have to. I'll give you sometime Monday, and it'll probably be due Wednesday. I may give you like 10 or 15 minutes in class on Wednesday, but I also think that might be the quiz. But regardless, let's start on
If statement review.
yes, if statement review. It does also contain lists and loops. So that just might be the semester 1 review. I may change the name of it, but
Okay, but it's not due on Monday.
I'm gonna change. It's not due on Monday. Can you put your phone in your bag? Thank you. So let me say. Then we're gonna start a new one. So this is gonna be review loops. So there are 2 loops that we cover: a for loop and a while loop. Who can tell me the difference? Give me what's a while loop?
A while loop keeps on running through itself until a certain condition is met.
Until a certain condition is met, yes. And a for loop, Brendan?
I'm pretty sure, it does, I'm not exactly sure, but it runs a certain amount of times.
Yep,
and-
that's it.
Yeah.
So yes.
Isn't a while loop with like all the true false statements?
It also,
Yep.
It also creates a variable. if you
Yes.
For X and Y.
Correct. All of those are correct. I break it down into a while loop is a condition-based loop, and a for loop is a count-based loop. Condition, a while loop. Do I know how long it's going to take you to guess a number between 0 and 100? So I would use a while loop, unless I wanted to force you to do it in a certain number of times. Do I know how many kids are in this classroom right now? Yes. So that's the difference. If I want to do something a certain number of times, or within a certain set of objects. So if I have a list of your guys' names, I can have for every student in my class, I need to do something. Or I could say, as long as students are in this classroom, I'm going to teach. So you can think of it, for everything, I'm going to do code, I'm going to do something. That's a for loop. Or I could say, as long as something is happening or not happening or whatever, as long as versus for every. So if I wanted to do if I wanted just to display every number from 0 to 10, the easiest way would be doing a what? Well, how many times do I want the code to run? 10 times. Is that a number or a condition? Number. So I would say, if I know I want to do something 10 times, do a for loop. And I would do for num in range 10. I can't just do 10. Because how many things are inside of 10?
2.
2, infinite, 0. 10 is a thing. It's a 10. It is an integer. However, if I do range 10, what range 10 is saying, give me the numbers from 0 to 10 minus 10.
Do I need parameters for range?
Yep, that's what 10 is.
Oh, really? You see one number?
Yeah, because that'll give me 10 numbers starting at 0. So if I have 10 numbers starting at 0, what is the last number that will be displayed?
9.
9. Yes. So if I wanted to display the numbers 0 through 10, what number do I have to put in here? 11, correct. And then I just print num. Yes.
What if you want like 1 to 10?
I would do 1 comma. So if you only have one parameter, one number in here, it goes from 0 to that number minus 1. If I have 2, it starts at that number and goes to the second number minus 1. If I, so we'll get 1 to 10. So I'm actually going to, so so you guys can have examples of it when you're going back to study. Because I know all of you are going to go back and study all of this, right? Yeah, I knew it. 1, and then if I do 1 comma, what does anyone remember what happens if I put a third number in there?
Oh, it's every other number.
It's every other number, yeah. Well, if I have 2, it's every other number, but if I have 3, it's starting at 1, and then the third number, and then the third number.
So it's 1, 4, 7.
What happens if you have 4 numbers?
It breaks. So yeah, what Stockton was saying, we have 1, 4, 7, 10, because what's 1 plus 3? 4. What's 4 plus 3? 7. What's 7 plus 3? 10. If we put a fourth number in here, I believe we get an error, because it's going to be like, it's going to wig out. Yeah.
There's only one.
Yeah, this function was only coded to have no more than 3 objects. No more than 3 arguments, thank you. Now, what if I wanted to count backwards? What if we're doing a timer?
Do 11 and then 1.
Well, let's do sec in range for seconds. What do we want to start at? We want to count down, so we start at 60. Where do we want to stop?
Negative 1.
-1, because we want what number to be displayed?
0.
0. And then how do we go backwards? -1.
1.
So I'm going to comment all these out. So this is where you start. This is where you want to end. -1 or +1? If it's negative, it's +1. If it's positive, it's -1. It's -1. And then this is how you want to, do you want to go forward? Do you want to count up? Now, if this was a positive 1, it actually doesn't print anything. Because you want to start at 60, you want to go to -1, but you're adding to 60. So you're going to go 61, 62. So what number is in between 60 and -1 if you add 1 to 60? None of them. So that's why it's not displaying anything. You can also, this is just a fun little thing. And now here we have a countdown. Oops, I forgot to put the minus there. Time.sleep pauses your code for however many seconds are in here. All right, so that's it. Again, all of this is saved online. So if you have any questions, I'm going to edit the homework, so you guys don't need to do that. We should cover loops on Monday, hopefully get through lists, and then you guys will have that assignment for homework, and then we'll have a quiz either Wednesday or Friday. I'm leaning towards Wednesday. That way we can do try and accept on Friday, and then you guys can have a little bit of a try and accept assignment over the weekend, next weekend. It won't be big. But again, this is a little bit of a faster paced class than the other one, than intro, so just be prepared for that. All right, have a great day. Everything's good. You guys are good to go. Have a good one. Have a great weekend.